Hello. So welcome to the new video. So in this video, I'll introduce the concept of rotational motion. Till now, we have discussed the in our previous videos, we have discussed about linear motion. Linear motion means the motion in a straight path or in a curved path, but it should be in a linear means that means the equations of motion v is equal to u plus at. These equations will be applicable there, and the motion can be moved either in the plus x direction or in the minus x direction. So all these things they are within the linear motion. So now we'll discuss the concept of rotational motion. Rotational motion means if a object, a rigid object, we'll discuss what is the meaning of a rigid object. If a rigid object will rotate about an axis, okay, then we will say then it is a rotational motion, the concept of rotation. So for example, suppose this is a mobile and this is your axis. Now the mobile can rotate like this. If I'll keep a mobile and just make a hole, then the mobile can rotate about this. The mobile also can rotate about this also, but we'll discuss that each rotation is a different case. But the important thing is when a rigid object revolves around a particular fixed axis, then such type of motions are called rotational motion. So we'll discuss about rotation. Motion of the rigid body or rotation we will discuss. So in this rotation, the main important thing is that is one fixed axis. Fixed axis. And the second thing is that a rigid body okay. So these two things are very important. So what is a fixed axis? Fixed axis means the object will revolve, or the rigid object rigid body will revolve about a fixed axis. That fixed axis is called your means axis of rotation or fixed axis. Then what is rigid body? Rigid body means the body which all total will revolve around that axis. All total means, like suppose instead of solid means a liquid is there, and if we'll rotate, or if we'll rotate a liquid object, then you see some part will be staged, will move first, and some part will be lagging behind. Or a gas is there, just you will try to rotate one gas. The gas will rotate means around about this axis. Let's say when the gas will rotate about this axis, what will happen? Some particle of the gas, they will move faster, some will be backside. But if suppose iron, solid, very rigid object, where the intermolecular distance will not change when they will rotate around the axis. Such type of objects are called rigid object, and in particular you can think of a rigid object is an object which is having means which all parts will move together, not some parts, other parts will lag behind, they will stage or deform. Okay, for example, suppose this is an object, any object, and this is your axis. This is your axis. This object is moving like this, rotating about this axis. Now suppose some part of this object is stretchable, some part will move first, other part will stay here, they will move slow, or they are gaseous, they are gas, let's say they are gas. Some part of the gas will move, another parts will be at the back side, they will move slower than this. So no, this is not a rigid object, rigid body. Rigid body means all the parts of this object will move completely, or they will move together. Okay, so this is your fixed axis, This is your rigid object or rigid body. Now, is the rigid body consists of many points. There will be some intermolecular forces or bonds, so that it's together, it forms an object or body. Now, in this rigid body, when it is moving or rotating about an axis, all the points of this body, they will also move with same speed. Okay, so here exactly the terms which we use for velocity in linear motion, like we use v, here we'll use omega, small omega. Okay, so it looks like w, Greek letter it's omega. It's omega. So it's angular velocity. It's angular velocity. Right. So when the object will revolve around about an axis, it will have the angular velocity instead of linear velocity. So don't confuse with all these letters. Just compare it with your linear terms. Like in case of linear velocity, we use velocity, displacement, and acceleration. So similarly, here also we'll use. Suppose I'll write this is linear, this is angular. So linear velocity v, angular omega. The symbol is omega. Linear acceleration a, angular acceleration alpha. Symbol, just symbol, nothing else. Okay. And relationship between linear and angular also, there is some relationship. We can calculate those relationships that I'll discuss in my next video. So in this video, what I'll discuss is, I'll just establish this relationship, means what are this angular velocity, what is this angular displacement and acceleration. So this is velocity, this is acceleration, and displacement, let me know, is S. Generally we represent in linear case. Now for rotational case, everything will come angular. It's not linear. Linear when the object was moving in straight line. Now everything when it is rotating, all the terms will be angular. Okay, so just don't confuse with the terms. So this is VAS here, omega, alpha, and AS we represent with theta. Theta symbol is known to you. Many times you have used in trigonometry, right? So theta is the displacement. So how this displacement will be there? So suppose this object is rotating about this axis. Now suppose this is another axis x, and this is your reference point. Let's say we are considering this is a reference line. Okay, and this reference line will also be about the same x-axis plane, which is perpendicular to this axis only, to the axis of rotation. For example, suppose this is the axis of rotation. Okay, this mobile is rotating like this. Okay, so if I'll consider this is x-axis, then after some time the mobile is here, so the axis of rotation is changing. Which plane? In the x plane, this plane, perpendicular to this one. So reference line, my reference line will change. This is suppose x, this is your x. Now reference line will change like this. Suppose reference line, initially the object is here, the reference line will change, so it will rotate around this axis. So reference line will also rotate, right? And reference line, remember, reference line is perpendicular to the axis of rotation. This is important. So this is reference line. So this reference line is perpendicular. This is 90 degree. Okay, and this reference line will rotate in this plane. This is this one. This reference line will rotate in the plane perpendicular to it. I say like this. So initially, let's say the reference. This is your reference line, and initially, let's say this is the object is at here. And the object after time t, it revolves around and this angle theta. So here how the object will move? The object will rotate around this one, means it will change its angle. Its angle will increase. Okay, the angle will increase. So displacement is measured in case of rotation case in terms of theta. Okay, and also will measure more precise, means in our use we will use pi. Okay, that I'll discuss now. What is the difference between degree and pi? That you know. So as I told you, so these are the terms which are associated with angular terms. Angular means when the object will rotate, then these terms will come, and in the linear case, B, A, and S. Now, what are these terms? Let us discuss one by one. So, the terms like theta, as I told you, theta is the displacement. Like in linear case, when the object moves, then it is moving in a straight line or in a straight single line, then it is a linear motion. But theta, when the rigid body will revolve around about an axis, then there will be change in theta, change in angle. So that change angle will increase. So displacement. So theta is displacement in case of your angular motion or your rotation case. Now, what is alpha? Alpha is the acceleration. Means if the object is rotating, rigid body is rotating about an axis, then how fast it is rotating? What is the velocity? Okay, that is your angular velocity, W, omega. Okay, looks like W, but it's omega. You will read like omega pronouns. So angular velocity is your omega. So how fast is now? What is acceleration? That the change of velocity, the rate of change of velocity is your acceleration. Means how fast your velocity is changing. That we means define acceleration, right? That is V upon T or V2 minus V upon T. Del V by del T. So this is your acceleration. So in linear case, now in angular case, same thing. How fast the omega is changing, how fast the angular velocity is changing. So if the angular speed is increasing gradually faster and faster, then the acceleration will also be there. Like in linear case, if object is moving in a constant velocity, then the acceleration is zero. Okay, V final minus initial is zero, so acceleration is zero. So here also, if the object will have the constant angular velocity, there will be no acceleration. But the object can move with a constant acceleration and a smooth increment of, means the rate of change of constant angular velocity. Okay, if the velocity will increase with a constant rate, then acceleration will be constant. It will not be zero. But if angular velocity is a constant, then it will be acceleration will be zero. Anyway, so as you can see, so these are just the representation. Other same means like just you compare with your linear case. Linear case is well known to you. Like velocity is what? Change in displacement, like S2 minus S1 by T2 minus T1. This is what we write for velocity. Okay, S2 minus S1 upon T2 minus T1. Or more precisely, you write for instantaneous velocity. What you write? You write that ds by dt. ds by dt. Similarly, what you write for acceleration? We write dv by dt for instantaneous acceleration. Or also you write v2 minus v1 upon t2 minus t1. Change in velocity upon change in time. Okay, rate of change of velocity is your acceleration. So we use dv upon dt for instantaneous acceleration. So the same concept will use for the rotational motion also. So what is the same concept? Here, instead of s, velocity, we are getting the displacement as theta, angular velocity. Okay, so what will be the velocity here? The same, d theta by dt. This is of course instantaneous, or average one you can write your omega. Average is, you can write theta 2 minus theta 1 by t2 minus t1. So you can write like this. That is initial, suppose this is theta 1, then after some times the reference line, the object rotated little, so reference line is here. This is your theta 2. So theta 2 minus theta 1 will give you the displacement, the net displacement, angular displacement, how far the object has rotated. Okay, so it will give you. So that's why you can write that omega is d theta upon dt. Similarly, alpha is equal to d omega by dt, and your theta is equal to, theta is the displacement. Okay, so this is what your, the same thing we are doing, just in place of, in linear motion we are taking displacement s, in linear motion we are taking velocity v, here we are taking velocity omega, and we are taking acceleration as alpha, and your displacement as theta. Okay, so this is just the difference between the your linear and angular. But angular case, here the object will revolve around the fixed axis, and the object must be a rigid body to obey this law. Okay, because we are taking a fixed axis. Suppose let's say the fixed axis, any axis which passes through the object. Now each point of this object, each particle of the object will also move in the same omega, same angular velocity. Okay, if the object is revolving about this axis with a omega object, the whole object. Now the particle of each particle, as it is a rigid body, each particle of this object will also move in the same angular velocity. This is the concept of the rigid body also. Okay, if it is not rigid, then this will not obey, because if it is a gas, then suppose some part of the gas is moving with omega 1, another particles will move with omega 2, some part will move with omega 3, they will not move with same angular velocity. So the object to be rigid, it must have the same, means all the particles must move in the same angular velocity. Okay, so this is the concept of your angular velocity. Now we'll discuss that how we get theta, means displacement. So remember the rule that the anti-clockwise, because theta is positive here angle, and we say this, the quadrant is a negative one, so theta is negative. That means clockwise motion, if an object will revolve clockwise, then we say theta is negative. Anti-clockwise theta is positive. Remember this, anti-clockwise theta is positive, or you can remember one thing, the clock is a negative theta, clock has a negative theta. Okay, negative displacement, you remember like that. So always we take theta positive for anti-clockwise motion, for anti-clockwise. For anti-clockwise motion, we take theta positive. For clockwise, theta will come like this. Then displacement will be in clockwise. For the clockwise motion, the angular displacement we take as negative. This one you remember just. Okay, like in case of linear motion, if the object is moving ahead, suppose this is your plus x, this is your minus x. If the object is moving to the plus x direction, then we say the displacement is positive. If the object is moving towards minus x direction, then we take the displacement is a negative displacement. Okay, so in the same way, we consider theta if it is anti-clockwise, you take angular displacement as positive. If theta is in the clockwise direction, then we take theta as negative. Okay. Acha. So now we have discussed that what are the relationship of this omega, what is alpha, and what is theta. Okay, now this theta is measured in terms of radian generally. Okay, so theta is degree, you know, and also radian. So because you know this relationship, right? The relationship is, suppose this is a circle, okay, and if this is your r, this is your s, let's say, and this is theta. So what is the relationship between theta r and s? Theta is equal to s by r, or s is equal to r theta. You can write that like that. Okay, theta is a ratio of your circumference by radius. Means, you see, So suppose the theta is, this is your in radian, this is your pi, and total is 2 pi. One revolution, this is called also one complete revolution, REV also we write. Okay, REV also write. So one REV, this relationship you can write is 360 degree. You can see this is 360 degree, and this is equal to, so what is the total path in a circle? The circumference of a circle is 2 pi r, right? So this is 2 pi r and r divided by r. S by r the formula. Now, so this is r cancelled. So 2 pi. Okay, r cancelled. This is 2 pi. This is 2 pi. So one revolution is equal to 360 degree is equal to 2 pi. So you remember this one. Okay. So generally you will use in terms of radian. Pi is in radian. So pi has a number 22 upon 7 or 3 point, that number, irrational number, you know. So that phi is discovered to means it's a very this constant irrational number is a very important number, so that we can find the perimeter or area of a circle using that number. Okay, so the concept of the perimeter, the ratio of the perimeter to the radius gives you theta, and that ratio is can be of your radian. Okay, and total one revolution is 2 pi radian. Accordingly you can calculate. Okay, 90 degrees pi by 2, 180 degrees pi radian. Like that you can find out the relationship between them. Okay, so this much we'll discuss in this class. Now we'll solve one problem based on this. This is very important. Then in the next class, next video, I'll discuss about the relationship between the linear case and the angular. How can you correlate? Because our life in angular case, in rotation case, is not that simple as it looks. In most of the cases, it will be complicated. So what we will do, we'll compare the linearity with the angular case. Okay, so angular will make a relationship with angular to linear, so that whenever we require, we can shift to our discussion to linear case. Okay, suppose a ball is rotating and moving ahead. So it's a both cases of a translational and rotational case. It's not purely rotational. In many cases, we'll require this, and also in many of the physics, will come across in such situations where if we'll go through this rotational case, the things will be more complicated and to solve the problems. So we have to shift that from rotation to linear case. We must get some relationship, some linkage, so that we can get the relationship in linear case, and we can convert the angular case to linear case. So we will discuss that in the next video, and we will calculate the relationship. So now in this video, let me solve one problem based on this, your angular velocity and your acceleration, angular acceleration concept. So this question is there in Halliday, Resnick and Walker. I think you must have this book, all of you. It's a very good book. Like you can think it's called a very nice book in physics, Principle of Physics, and the author is David Halliday, Resnick and Walker. Okay, you can purchase this book. It's a very good book for the fundamental and the problems also. Okay, so you can try this book. So one problem is given in 10.2. So let us discuss that problem. So we have solved this type of problem in linear cases. So now we'll discuss this problem in case of angular motion. So the problem is, angular acceleration is given. Okay, angular velocity derived from angular acceleration. So angular acceleration is given. So angular acceleration angular acceleration is given as alpha is equal to 5tq, alpha is equal to 5tq minus 4t. Okay, alpha is equal to 5tq minus 4t. The question is, calculate the means angular acceleration given. So you have to calculate A, omega, that is angular velocity, and B, theta, displacement also you have to calculate, and the condition is given. What is the condition? The condition is given at t is equal to 0, okay, at t is equal to 0, your angular velocity is 5 radian per second, omega is equal to 5 radian per second. Acha, what is rad per second? Radian per second is the unit of angular velocity. Like in your linear velocity, what is the unit? Meter per second. Okay, meter per second is the unit of linear velocity, because displacement is measured in meter, velocity is s by t, right? S is meter, t is second. But here omega, as I have written, is theta by t or delta theta by delta t, okay, or d theta by dt. Delta means just change, that means theta 2 by theta 1, theta 2 minus theta 1 by t2 minus t1, like that. So theta is measured, as I told you, radian, and time is second. So radian per second is the unit, SI unit of omega or angular velocity, right? So at time 0, your angular velocity is 5 radian per second, and at time 0, the angular displacement is 2 radian. At time 0, omega is 5 radian per second and theta is 2 radian. Okay, that means suppose the object is here, it is rotating about this axis, let's say, and at time t is equal to 0, let's say the object is moving, the object starts from here. Okay, so this is t is equal to 0, the theta is already 2 radian, let's say, and at this point the speed of the object, angular speed, is 5 radian per second. The question is calculate omega and theta. Okay, so how will you calculate? So we'll use the formula. What is the formula? The formula is, first let's calculate omega. Alpha is given. Alpha is equal to what? Alpha is acceleration. So acceleration is change in velocity, rate of change of velocity. Angular velocity, here in rotational case everything angular. Linear case just we are writing velocity acceleration. In angular case everything means rotational case everything is angular. So alpha is angular acceleration. So angular acceleration is derivative of, or instantaneous case is d omega by dt, rate of change of angular velocity. Now what is, I can write the angular velocity is alpha dt. All of you I think are acquainted with this integration, as I have also made 2-3 videos on integration, the basics of integration. Okay, you should go through those videos. In my previous classes I have made few videos based upon integration, because mathematics and physics both are related to each other. Okay, you should, without solving good mathematics you will not able to solve these problems. So you should be good at mathematics also. Listen, so here d omega is alpha dt. So how will you calculate omega? So integrating both sides, You will integrate both sides just, then you can get alpha. Okay, like in our linear case, we had discussed, na, A is equal to dv by dt, or dv is equal to a dt. So we have done like this, and v is equal to a dt integration. We have done like this. Okay, these are indefinite integral, plus c will come, and plus c will calculate from this condition. Let's see how we are proceeding. So this type of question comes in many times in the different your entrance examination also. Now you see. So d omega, integration of d omega is omega, right? Integration of dx is x. You should know this integration. Now alpha is given this equation. So I'll replace this alpha as 5tq minus 4t, and this is dt integration. Okay. Now what you will do? Just separate. You can just separate the terms, right? Integration of 5tq minus 4t dt, dt minus, means if plus or minus is there, then we will have to find the integration for individual terms. I think the integration part is known to you. If you do not know how to do these things, so you should follow my videos on integration, or you can try from any notes. Okay, so 5 is constant comes outside, and if a power is there, variable power is there, like x to the power n, then the integration is x to the power n plus 1 upon n plus 1, right? So here 5 will come outside. This is t to the power 4 by 4 minus 4, this is power 1, so t square by 2 to cancel, and plus c will come, one constant will come. So what we got? We got your omega as 5 by 4 t to the power 4 minus 2t square plus c. This is what we got here, omega. This is what we got, the omega, angular velocity. But we do not know the c. We want omega as a function of t. Okay, we don't want c. So we should calculate c. What is c? Then only we can get the omega as a, means explicitly it should dependent upon t only. Okay, we'll get some function that will be only dependent on t. Omega will be a function of t. So how will you calculate that? So that will calculate using the concept, okay, of this condition. Condition is what? At time t is equal to 0, omega is 5 radian. So I will use this equation. I got omega is this. So omega will be 0 when t is equal to 0. Omega is equal to 5 when t is equal to 0. So just I'll put t 0. So this 0, 0 plus c. 0 plus 0, 0 minus 0 plus c. Or you can say c is equal to 5 radian per second. C is equal to radian per second. Okay. Okay. Now, then your omega will become a function of t. That is what our question. Find the omega explicitly dependent upon t, or omega of t and theta of t. Find that. Okay. Or if the time will be given in the question, that calculate the angular velocity at time t is equal to 2 seconds, let's say. Okay, then you can put time t is equal to 2 seconds and you can calculate what is your angular velocity. Is it okay? Okay, so if just it is asked calculate omega, angular velocity as a function of t, then you can calculate omega of t. But if time is given again, then calculate the angular velocity at time t is equal to 2 seconds. Then you can calculate omega at time t is equal to 2 seconds. Just you will put in place of t, you will put, and you will get the omega, your angular velocity. Now you see omega of t, you are getting this expression. So What are you getting? 5 by 4 t to the power 4 minus 2 t square, and c we got cos 5. So this is what the omega you are getting. This is the angular velocity you are getting. Now we will calculate theta. So how will you calculate theta? Like if velocity is given to you, how will you calculate the further displacement? So you have to integrate velocity, right? Like you have done for in linear cases. Means just compare, think and relate with your linear cases. Then things will be easy. Okay. Just notation difference. Think like that. It's just a notation difference, nothing else. So omega, we are getting omega this. Now we are interested for theta, because we know that omega is equal to d theta by dt. Omega is equal to d theta by dt. So d theta is equal to omega dt. So integrating both sides. These are indefinite integrals. These are indefinite integrals. That means boundary is not known to us. Lower limit and upper limit is not known to us. If boundary is given, then no need of these conditions. All will get a value. Okay. If boundary is not given, then we have to use a c. To calculate this constant c, we have to use some conditions. It must be given to you, or a known condition. There are cases where you can also predict some conditions, like in case of the boundary problems, or how you discuss the higher problems like tunneling effect, all these things. Here, the boundary, you have to predict the boundaries. Now, so integration of d theta is equal to omega dt. What is omega dt? Omega is this one, 5 by 4 t to the power 4 minus 2 t square plus 5 whole dt integration. Now directly I am doing constant outside, and t to the power 4 is 4 plus 1 by 4 plus 1, n plus 1 by n plus 1 formula. So t to the power 5 by 5 minus 2 t to the power 3 by 3, n plus 1 by n plus 1 plus 5 dt integration is t plus a constant, let's say c prime. C prime, just I have taken another constant because c I have used for omega on constant. That is, this constant will not be 5. This is different than your previous constant. That's why I have written c prime. Let's say c prime, another constant, or a k you can write also. No issue. So 5 got cancelled. So what are you getting? Theta as a function of t you are getting as 1 upon 4 t to the power 5 minus 2 upon 3 t cube plus 5t plus c. So what is the theta you are getting? You are getting the theta as this one. Now c prime. You have to get c prime. Then only you can calculate the final expression. Okay? So how will you calculate c prime? The same technique we will use. That this condition is given, t is equal to 0, theta is 2 radian. So theta is 2 radian for t is equal to 0. Now I will put 0 everywhere, right? T is 0, 0, 0. So is equal to c prime. Okay? So c prime is 2 you are getting. 0, all the terms 0, right? 0, 0, 0. So you are getting c prime. Now what is the final expression then you are getting? You are getting theta t is equal to, let me write here, I think I can write. So I am getting theta t is equal to 1 upon 4 t5 minus 2 upon 3 t cube plus 5t. Okay, so c prime is equal to 2 radian. The displacement is in radian. Okay, 5t plus 2. So this is what you are getting theta. Clear? So you got theta, that is your angular displacement. You got your angular velocity, that is omega, and for the initial condition, and we have used the initial condition, that is t is equal to 0. These are the velocity, this is velocity, and this is angular displacement. And we have used these conditions. After using this condition, we got the constants. We could calculate the constants. Okay. So once we calculated the constant, then your expression is ready. Now, if for any time, once you get an expression, explicit expression in terms of time, so for any time you can calculate what is the position of the object. Okay, as the object is revolving around an axis. So once you get the theta, so you can calculate at particular time, at 5 seconds, at 6 seconds, at 7 seconds, what is the exact position of the object. You can easily calculate the theta, and also you can calculate. We have one equation for your omega, angular velocity. So at particular position, at time t is equal to 5 seconds, what is the angular velocity? Someone will ask. So you can easily, after as your expression is ready with you, so you just put the value of t in that equation and you will calculate the angular velocity at that time easily. Okay, so this is how we solve this type of problems. So it's same like if acceleration is given in case of linear cases, then calculate velocity and displacement, and the condition will be some initial conditions will be given. So using that, you have to calculate the displacement and velocity in case of linear cases. But here again the same thing we are doing, but the notation is just different. So don't confuse with the notation. Just compare and correlate with your discussion in linear cases. Okay. So in second video, we will discuss and we will relate the linear cases to angular cases. We'll find some linkage. Then we will discuss mass, center of mass, moment of inertia, and we'll calculate the moment of inertia for. In another video, we'll calculate moment of inertia for ring, disk, and other some sphere, some different figures. Okay. So we'll stop here for this video. So you can join the Telegram group. I can share the description in the description link, so that we can discuss few more questions over the period of time, and so I can provide some study material also there if you are practicing for the different competitive exams. Okay. So thank you. Let's stop here.